चलो स्टार्ट.
Uh, Hello friends, I am Ghulam and today I am out here to give a lecture on thermal radiations. So first of all, what is thermal radiation? Thermal radiation is the emission of heat in the form of electromagnetic waves. So the emission of heat, this takes place due to some activity within the atoms of a body. What is this activity? This activity is nothing but the shifting of electrons from the orbit. Okay. So now the emission which are taking place from our bodies are mainly in the range of a wavelength of 0.1 to 100 micrometer. Okay, so under this range it's coming ultraviolet ray, light ray and infrared ray. So in simple we can tell thermal radiations is nothing but a light ray, infrared ray and an light ray, infrared ray and ultraviolet ray. Okay, so now I would like to come to the idea of an opaque body before coming into the black body. I have written this already because short time is given to me for giving lecture on it. Okay, so first of all, what is an opaque body? So suppose this is the surface. Okay, and in this you can see a black dot. This is an atom from which the emission is taking place. This red colors is the emission direction that is taking place all around the atom. So what happens? This energy which is emitting from this atom is not reaching to this surface. It is absorbed by the nearby atom only. Understand? It is absorbed by the nearby atom only. So the energy, now one more thing, if any energy is incident on this surface, this energy is not coming here, it is absorbed by the surface atom only. Understand? So the two things here we have to keep in mind is that the energy emitted by this atom is not reaching to the surface because it is absorbed within the nearby atom only, and the energy which is incident on this surface, this energy is not reaching here because it is absorbed by the surface atom only. Understand? Now another thing is that suppose the emission of a body depends on 3 to 4 main factors. Okay, what are these factors are mainly the temperature, number 2 is the roughness, number 3 is the material, number 4 is the wavelength. Understand? So on the basis of this, the emission of a body we decides. Suppose there are 3 to 4 bodies, suppose there are 4 bodies, okay, which are maintained at the same temperature, but their material is different, rest all properties are constant. So what happens? There is going to be a surface which maximum emission and with minimum emission. Okay, so the body with the maximum emission is nothing but a black body. The black body is the ideal concept. It is a hypothetical concept. Actually it doesn't exist. It does not exist actually. Since you know thermodynamics very well, so you can understand in between the source and the sink, if we are going to place any engine like petrol engine, diesel engine or any other engine, it will have the certain efficiency. Okay, but if we are placing between the source and sink the Carnot engine, it will have the maximum efficiency. So but Carnot engine actually it does not exist. It is a hypothetical concept. In the same way, the black body is also the hypothetical concept. So the first thing about the black body, it is an ideal concept. Second thing, it is a perfect emitter. Perfect emitter means it emits maximum amount of electromagnetic radiations. Understand? Third is the perfect absorber. Whatever energy incident on a black body, it is going to absorb all the energies. It will not reflect any energy, it will absorb all the energies. For example, if we take an example of a glass, light plus infrared is coming to the glass. So what happens? The light passes through the glass but infrared gets reflected, so it is not a perfect absorber. Understand? Fourth one, diffuse characteristics. See, diffuse characteristics for the black body, it means it is independent, the emission is independent of the direction. I can show you like this here. Real body, suppose there is a real body, this is not a black body, so in this the emission takes place like this. Okay, means it depends on the direction. You can see that it is all the energy emission is taking place in this direction. but when the terms came for the black body, what happened? You see, its emission is like this. It's all around the point. Okay, so it is encompassed by a hemisphere. So emission for the black body, it emits in all direction. So it is independent of the direction. Understand? Now there are three basic laws for the black body radiation. The first, which is the fundamental law, is the Planck's law. Second is the Wien's displacement law, which is derived from the Planck's law only. Third is the Stephen-Boltzmann law, which is also derived from this Planck's law. See, in short, I will tell you, the Planck's law, it just gives the relation between the radiant flux per unit wavelength, that is the black body emissive power with respect to the wavelength. It is the relation between the emissive power of a black body with respect to wavelength. Okay, but when we differentiate this equation, we get Wien displacement law, and when we integrate this equation with respect to the wavelength, we get Stephen-Boltzmann law. Okay, so see, if we differentiate this, d Eb lambda by d with respect to the wavelength equal to 0, we get Wien's displacement law, and on solving this, what we get? Lambda maximum T is equal to constant. This is, what does this tell? At the higher temperature, the emissive power of a body shifts towards the shorter wavelength. Understand? But if we integrate this equation, we get Stephen-Boltzmann law. Eb lambda, d lambda. Okay, if we integrate this equation, what we get? Stephen-Boltzmann law, and according to this law, it is said that emissive power of a black body is sigma T to the power 4. Okay, sigma is the Boltzmann constant. It has certain value, 5.67, 5.68 into 10, 5.78 into 10 to the power minus 8. Okay, so this is the Stephen-Boltzmann constant, and this is the surface temperature, and this is the emissive power of a black body. If we talk about any real body, its emissive power will be what? Its emissive power is what? Emissivity of that body. This is the emissivity, sigma, and the temperature of that body. Emissive of any real body. This is real body. Okay, this is real body. Understand? So there is many more thing to teach. If the time permit, actually the time does not permit to teach. So I hope if we meet again, we will discuss more in detail. That's all. Thanks.